So we'll start with that basic theory of operation. What this thing is, how it works. We'll cover some of the security around it. I'll show you how to turn it on manually and via group policy object. And along the way there, we'll cover some of the more interesting configuration settings that you can fuss with. And I'll show you how to use this thing in very basic form. We'll do a one-to-one connection between two computers, and we'll do a one-to-many connection to several computers, so we can start to kind of build up that multiple computer management thing, which is really what remoting is just designed to make easier and frankly very cool. So let's start with some theory of operation. Now, from a terminology perspective, we're going to say that you and I are sitting in front of a computer. We'll call that the local computer. And it's often going to be a client operating system because that's often what we've got running on our workstation that's actually at our desk. Now from there, we are going to connect to one or more remote machines. Those might be servers. Those could be computers running another client operating system. It doesn't matter. So long as the remote machine has had PowerShell remoting enabled for incoming connections, we're good to go. We don't need to do any enablement on our starting point, on the local machine. Remoting is always enabled for outgoing connections, but provided any local firewall software is allowing the connection out, of course. So in terms of protocol, the actual protocol being used to make that connection is called Web Services for Management, WS Management, or more commonly, you'll see it as WS-MAN. Now, in the Windows operating system, there's a service called Windows Remote Management, or WinRM, that actually implements that protocol. And the protocol is built on top of HTTP or HTTPS. In fact, the default ports are 5985, or if you're using HTTPS, 5986. Now there's two ways to use this. There's the first way, which I call one-to-one, or I guess you could call it interactive or ad hoc, so we'll call it one-to-one for now. And that's me sitting on my client computer connecting to a single computer. Now from a use case perspective, this feels a lot like the SSH protocol that's so common in Linux and Unix operating systems, but it works very, very differently. SSH is basically an evolution of Telnet. What happens is you get your SSH client software running on your computer, you push a button on your keyboard, that gets sent to the server, which echoes it back, which causes it to be displayed on your own screen as well. WS-MAN doesn't work like that at all. Instead, in WS-MAN, you're going to type your entire command, and when you hit enter, the entire thing gets bundled up into an XML packet and sent to the remote computer. The remote computer then executes that, does whatever's necessary, takes the results, which, because this is PowerShell, the results are going to be objects. It serializes those into XML. This is not that different from using convert to CLI XML. Now, in fact, the XML format is a little bit different, but you don't need to worry about it because when that XML arrives at your computer, it gets decoded or deserialized back into objects. So from your perspective, it's all objects top to bottom. XML is just used as a way of transcribing those into text so that they can be easily transmitted across the network. Now there are a ton of configuration settings that we can play with on this thing to customize it, and we're going to walk through all of those. The other main use model for this is called one-to-N or one-to-many. And that's where I sit here on my computer and I come up with a command, or I might even come up with a whole script file full of commands, and I transmit those commands to multiple remote computers. They all execute that, and they're doing this in parallel to a degree, and then the results come back to me in the form of XML, which gets translated into objects. So this is really where multiple computer management sets in. And again, lots of configuration options, gonna cover all of them. From a security perspective, this is kind of an important piece, obviously. Let's just focus on this scenario where I'm in a single domain with my client and whatever computers I'm managing. In this case, the default authentication protocol is going to be Kerberos. Now, it means that when I go to connect to a remote machine, I have to refer to it by its actual name as it appears in Active Directory. And that's because the remoting system wants mutual authentication. Now, yes, your credential is going to be delegated via Kerberos over to the remote computer. So whatever you've asked it to do, it is going to do as you. So whatever you've got permission to do, it'll do. Anything you don't have permission to do, it won't do. If whatever you ask it to do would normally be audited, like let's say you ask a domain controller to delete a bunch of Active Directory users. If you normally audit that activity in your environment so that someone deleting users in Active Directory users and computers, well then that same action is going to get audited the same way if you perform that action through remoting. So this doesn't really add anything to security and it doesn't take away anything from security. But there's a trick here. You're sending your credentials to this remote computer. Think about that for a sec. If you've got a family, or you've ever been in a family, then you've probably had an opportunity to loan the car keys to someone. Let's say you're a parent and you need to loan your car keys to your 16-year-old son or daughter. Okay, fine. You've come to the point where you're at least somewhat comfortable doing that. You're going to hand the keys over. But before you actually hand the keys over, you want to make sure that's actually your son or daughter. And the way most of us do that, just automatically in our brains, is we look at their face. Yep, that's you. And you hand them the keys. Now imagine going out into the school gym one day, and all of the students have got paper bags and masks over their heads. You can't tell who any of them are. They're all wearing identical clothing. They're all the same height. They're all the same weight. You can't tell who any of them are. Are you going to hand your keys out? Well, no, because you can't mutually authenticate. Now, when you hand your keys over, they know it's you handing the keys, but you don't know who they are. Well, remoting feels exactly the same way. It doesn't want to transmit your keys until it knows who's on the other end. In a domain environment, Kerberos handles that automatically, provided you connect to a machine using its Active Directory domain name. Because Kerberos can look up that machine, get all the right certificates in place, and make sure that mutual authentication occurs. That same mutual authentication can occur if you're going to a different domain or a different forest over a trust relationship, because the protocol is designed to do that. Where it all falls apart is if you need to go to a computer that is in an untrusted domain or that isn't in a domain at all. Right there, because we're no longer able to use Active Directory, the Kerberos protocol is out of the question. You might want to choose to use the BASIC protocol. Now, the downside of the BASIC protocol is that your credentials are now being transmitted in clear text. That's username and password, clear text, coming over here. Probably not what you were hoping for. Well, that's okay. Because another problem we have is that there's no way for my computer to mutually authenticate the remote computer. You know, if I say, look, I want to make a connection to FDC, there's no way for my computer to verify that this is in fact FDC. For all I know, it could be some other computer that's spoofed DNS and is intercepting my connection to FDC, and it's waiting for me to send over those juicy username and password credentials. Well, remoting actually won't let you do that by default. And there's two ways it will require you to work if you want to connect to an untrusted domain or to a computer that isn't in a domain. Way number one is to put an SSL certificate on this computer. That SSL certificate provides you with the mutual authentication. You connect to the computer, say, hey, I need a copy of your certificate, dude. It sends your certificate. You, over here, have to be configured to trust whatever certification authority issued this certificate. And that tells you, yeah, you know what? I know that certification authority's process. I know they did a good job of verifying his identity before they issued the certificate, so I'm going to take their word for it. That's really what certificates are all about. Now, a plus is that once you're over HTTPS, your credentials are encrypted. Right, so now you don't have to worry about those credentials, username and password, going in clear text because HTTPS is going to protect them. That's the preferred way. Now, some folks don't like that as much because it does require you to get certificates. You should really, if you're going to use remoting, you should think about standing up a public key infrastructure if you don't have one so that you can easily get those SSL certs. But sometimes an SSL cert is just overkill. Let's say I've got a remote machine and it's in a lab environment. This is a brand new machine. I'm provisioning it. I'm getting it set up for the first time. I don't want to have to physically log on to it to install a certificate just so I can connect and start provisioning it. So the other trick is on your computer, you manipulate something called the trusted hosts setting. And this is simply a list of names or IP addresses that you will allow your computer to connect to without mutual authentication. Now, you're still going to have to select an authentication protocol, and Kerberos isn't going to be on the table. And if you've chosen basic, then it's going to be clear text. NTLM is a choice. That's also there too, and we're going to see where to turn all these things on and off. So you'll pick your authentication protocol. You tell your computer, look, there's no way this could possibly be intercepted or spoofed. It's just impossible. I control the entire infrastructure. So I'm going to add this to my local trusted hosts. That's going to allow my computer to connect. I still have to authenticate to it, but I'm not going to require it to prove that it's who I think it is. So I'm turning off the mutual authentication. Now look, you're going to get online and you're going to see people say, look, if you're connecting to a machine that's in a different domain or in a work group and you don't want to do certificates, then just set trusted hosts equal to star, and that'll make the error go away. Yeah, that'll make the error go away. You could also walk into the high school gym and hand out your keys to whatever kid in a mask walks up to you. This is a bad security idea. In a lab environment, something like that, fine. In fact, I used to teach this class, and I used to always do this just because, we're in class, it's a lab environment, but I'm not going to do that for you here. We're going to talk about exactly how to set up certificates. We're going to talk about how to set up trusted hosts. We're going to cover all the real-world configuration for all of these different communication scenarios so that you can actually see them work. I will tell you this. If you lose track of anything and you want a nice little walkthrough, go to PowerShell.org. And in the books page, look for Secrets of PowerShell Remoting. That's got screenshot walkthroughs of all the different things I'm going to show you so that if you lose track of something and you need a quick reference to how to do one of these configurations, yep, you can obviously come sit here and rewatch the nugget, or you can just go there and it's a quick walkthrough. Now that book isn't going to try and teach you anything. It's really just a configuration reference because some of these things involve multiple steps. In fact, some of them involve enough steps that I can't even really keep them straight in my head. So I'll have that up on my other monitor while I'm walking through the configuration because I use that as a configuration reference as well. A lot of what we're going to do was established in PowerShell version 2 and hasn't really changed a ton. So we'll start here in version 2. I'm on a client computer, and that means that remoting is not enabled by default. As of right now, Microsoft does not enable remoting by default on any client operating systems. And what they have done is enabled remoting by default on Server 2012 and later. So my domain controller and my domain's member computer are both running 2012, so they're going to have remoting turned on by default. But since we're on a client operating system here, we need to get that configured. A couple of ways to do it. The easy way to do it to a single computer is to be logged on as administrator and enable PS remoting. Now I'm kind of half hoping this pops up with an error, and even if it doesn't, I'll tell you what it does. This is gonna, oh, no errors. Yes, all. Okay, here's what this is doing, and then I'll tell you what that error might have been. There is a service called WinRM that is being set to start automatically and is being either started if it's stopped or restarted if it was already running. It creates a listener which will accept requests on any IP address, and we're going to talk about what those listeners are, and then it will enable a firewall exception for incoming WS-MAN traffic on HTTP. The listener that it sets up is also HTTP. And you can actually see here at the bottom of the screen this last message. This was it creating the Microsoft PowerShell 32 configuration. So the error that might have happened on client computers, particularly if you've got a client computer with like VMware Workstation or something installed, you have all these virtual NICs, all these virtual Ethernet adapters, right? Like if I run ipconfig all, I probably don't have any of the faked out virtual now because I don't have VMware Workstation installed on here. Well, what happens is those virtual network adapters get tied to a public network. You know, in Windows 7, you can tell a network to be home network, office network, or public. Well, if you have any network adapters that are identified as public and they're connected, or Windows thinks they're connected with a virtual one, it always thinks that, then the Windows firewall won't allow any exceptions. And so enable PS remoting will fail when it tries to create the exception in the firewall. So it's on you to figure that out. You've got to detach those public NICs from your system so that they're not seen as connected, or you need to reset their type so that they're not seen as public. So that's the easy way to do this on a single computer. The process is the same on Windows 8. The only difference here, let's take a look at that command, help enable PS remoting. The only difference is Microsoft kind of understood that business with the public network adapters was happening. So we've got a -skip network profile check. Now what that'll do is it'll actually create the firewall exception by default, even if you have a public network. But keep in mind, Windows itself will not allow firewall exceptions on a public network connection. So while this will allow the firewall exception, it won't necessarily mean everything will just magically work. So let's try enable PS remoting. I am sure. Whoops. Let's see here. Firewall exception will not work since one of the public network connection types on this machine is set to public. Awesome. I was kind of hoping we'd see that. All right, let me try it again with skip network profile check. All right, so there's the firewall exception. WinRM was already set up. WinRM has now been updated. It created the WinRM listener, and we're going to talk about what those listeners are. The firewall exception is enabled. And now, because I'm in Windows 8, this is actually going to create more endpoints, more session configurations. And again, going to talk about that architecture in just a sec. So the one we're creating now is... Okay, this is just allowing selected users to remotely run Windows PowerShell commands. So this is part of the security piece of this. Yes, I'm sure. And now we're setting up, so that was the Microsoft PowerShell configuration. Now we're doing one for PowerShell workflow. Yes. Now we're doing 32-bit PowerShell. Now we're doing server manager workflows. And each of those has a SDDL, security definition descriptor language, which is basically the gobbledygook here. We'll talk about that later too. And that is telling me what users are allowed to connect to this thing and actually run commands. So this is now all set up. So talk a little bit about some of those architecture pieces too. So let's say that this is the originating computer. And over here, we've got the remote computer. Now, there's a few different things going on. First of all, you are going to be connecting to the WinRM service on the remote computer. And you need to actually connect to a listener. And a listener is a combination of protocol, HTTP or HTTPS, and one or more IP addresses. So it's listening on that protocol on that IP address. Now, WinRM isn't tied specifically to PowerShell. WinRM is designed to pass messages along. So in order for an application like PowerShell to get those messages, it has to set up an endpoint, also called in PowerShell a session configuration. So the traffic goes like this. You target the particular computer with a particular IP address with a particular protocol. That attaches you to the listener. And because you're using PowerShell on the originator, there's like a little envelope. It says, dear remote computer, please pass this along to PowerShell. Well, so WinRM looks to see if there's an endpoint registered, passes the information along, PowerShell does whatever it's going to do, and the results get sent back. So what we just saw was PowerShell setting up those endpoints. Now, each endpoint has its own unique configuration, including who is allowed to connect to that endpoint, what they're allowed to do in it from a very broad perspective, and it can also preload modules, it can pre-run scripts, it can, in the case of PowerShell, it can restrict the environment so that there's no scripting language and so forth, and we're going to get into all the configurations around what you can do with those endpoints. So it's kind of important to remember that because it's completely possible to set up multiple different listeners. The external IP address that's internet accessible doesn't get a listener hooked up to it. The internal IP address that's in our DMZ gets an HTTPS listener hooked up to it. That type of thing. So you can really control the listeners, and that's all WS-MAN traffic. Then you can set up multiple endpoints that allow different people to connect to PowerShell and do different things.